So PM 2.5, again, we mentioned several times. Every time we look at a pollution, we also have to be sure that it doesn't have any positive feedback. So you always have to look for its sources, its concentration, its lifetime, and its global warming potential in some cases, as well as its impact on circulation and thermodynamics, so that you know that there is no positive feedback, or if there is, then you have to be very keenly aware of it, like tropospheric ozone's impact on plants and their ability to take up CO2, for example, would not only make ozone is a very strong global warming greenhouse gas, but it can also increase CO2 by affecting vegetation. So similarly, effects of particulate matter on different components of the atmosphere are shown here. In the upper atmosphere, it affects albedo, cloud formations that we already talked about, direct and indirect effects. So that affects Earth's radiation budget at the top of the atmosphere. They are parts of the chemical reaction processes in terms of providing surfaces, like for cloud condensation nuclei, and they can scatter and absorb sunlight and change radiation budget as well. In the lower, so upper atmosphere processes are what determine radiation budget. In the lower atmosphere, we have all these other things: ambient air and health effects, and we have biogeochemical cycles being affected, atmospheric visibility, local climate, and so on. And natural sources of dust include, of course, volcanoes, forest fires, wildfires, which we will talk about again, desert dust, seismic activity, biological activity. There are many aerosols emitted by vegetation as well, and of course sea spray puts out several billion tons of cloud condensation nuclei and salt particles. There are industrial activities, biomass burning, mining activities, vehicle emissions, construction activities, fossil fuel burning, and so on, that are anthropogenic sources, and they all have feedbacks with each other. So this is something we must keep in mind. For example, if dust, especially carbon particles, get deposited on snow and glaciers, we know that that accelerates the melting rates of those things. Just in terms of apportionment of PM 2.5 in selected cities across the world, just look at the typical sources here. For example, in Florida, you have sulfates, gasoline-powered vehicles, diesel-powered vehicles, and road dust, various percentages, a lot of it coming from sulfate. In Santiago, Chile, vehicles, wood burning, sulfate, marine aerosols, smelters, industrial activities, and soil dust. Let's look at New Delhi here. Undetermined sources are large: secondary inorganic aerosols, salt aerosols, and mineral matter. Let's look at Beijing here. Biomass burning, secondary sulfates, secondary nitrates, coal combustion, industry, motor vehicles, road dust, and others. So the point is that there are sources of PM 2.5 all across the world, and the exact source depends on where you are. In Barcelona, Spain, for example, secondary vehicle contribution is 73%. This doesn't say that Barcelona is a bigger emitter than Delhi or Beijing. It just says that the source apportionments are very different in all these different cities. Okay. Keeping that in mind, health effects of PM 2.5, sore eyes and inflammation, but the respiratory system damages are the worst ones: stuffy nose, sore throat, coughing, shortness of breath, and chest pain. All these things get exacerbated with ozone and the smog problem. In the lungs, you have bronchitis, emphysema, lung disease, and cancer, rashes, dermatitis, and urticaria in skin. Cardiovascular system is highly affected by PM 2.5. Arrhythmia, sudden cardiac arrest, heart attack, ischemic stroke, and ischemic heart disease. Those are kinds of health terminologies that we will visit later on. And threats to patients who are asthmatic or have allergies, lung diseases, lung cancer, emphysema, coronary artery diseases, and so on. And there have been persistent reports that COVID is exacerbated among people exposed to pollution. So there can be compounding and confounding effects of pollution on body's response to other pathogens and so on. So really something that is dangerous. Wildfire pollution. Wildfire is not just, we talked about it before in terms of air quality and climate change. We talked about how human management of wildfire actually shows that wildfires may not have increased in number, but the areas burned and the cost of containment have gone up. And people are of course living closer and closer to wildfire vulnerable regions as well, like woodlands and so on. But wildfire is also enormous polluter, and it harms health, especially in terms of its contribution to PM 2.5 and black carbon, and also ozone, carbon monoxide, sulfur, and so on and so forth. So eye, lung, throat irritation, heart disease effects are worsened by pollution related to wildfires. Premature deaths can be attributed to those. Of course, asthma attacks and breathing problems. This is just re-emphasizing the impacts of PM 2.5, of course. Okay, droughts. Maybe I will leave this for the next podcast. This is now little short, but that's okay. I want to visit drought because well, let me go ahead and include it. What the hell. Okay, so we looked at drought before in terms of the cascade through water shortages, livelihoods, food shortages, food price increase, forced migrations, and so on as indirect health effects, and then various nutrition-related effects, mental health, vector-borne diseases, airborne and dust-related diseases. So here we are focused on this part, and that of course increases morbidity and mortality as well. The Dust Bowl of the 1930s in the US was clearly a manifestation of drought-related dust loading in the atmosphere, and we've talked about things like meningitis in West Africa and the Kawasaki disease and so on that are related to dust loading and winds and so on. But droughts also exacerbate air quality, which is the focus of this chapter. So droughts themselves in winter in southwest China, for example, you can take other regions like India or Brazil and you will get similar pictures. A La Nina event, Arctic oscillation, conventional Eurasian teleconnection, Western Atlantic, Western Russia patterns. These are climate patterns. North Atlantic oscillation, which we talked about, which all affect the winter droughts in southwest China. They can cause high temperature, high sea level pressure, reduced precipitation, lower boundary height, so the planetary boundary layer is altered, and relative humidity is reduced, leading to unfavorable dispersion conditions. So even if the same amount of dust is being produced, it's not being swept away because of these changes. Remember, a large part of China is affected by the Gobi Desert dust coming over and can put lots of haze and dim the sunlight during the days and so on and so forth. Of course, have health effects. So these unfavorable dispersion conditions tend to make air quality much poorer and then affect health as well. Okay, so there. I included drought as well into this, and we will now come back and look at some of the future projections of air pollution. As you can imagine, news is not good. We will mostly look at ozone and its impact on crop production and food security as well. And then we will get into some specific issues of adaptation, mitigation, and make some conclusions based on what we have discussed thus far about air pollution and correlates with health. Okay.